Dear all, in our previous lecture, we have seen the applications of adsorption at solid interfaces. We can have adsorption of gases taking place onto the solid surface, giving us multiple applications. Similarly, we can have adsorption of adjacent liquid taking place onto the surface of solid and having multiple applications as well. Now, let us move and talk in detail about adsorption of gases onto the solid surface. So in solid gas interface, the degree of adsorption of a gas onto the solid, it depends upon four important factors. The very first factor is the nature of the adsorbent and the adsorbate. Adsorbent is nothing but it is the material that adsorbs the given gas molecules, and adsorbate are the material that get adsorbed onto the surface of adsorbent. Second important factor that affects degree of adsorption is the surface area of the adsorbent. Higher the surface area, higher will be the adsorption taking place. Third important factor is the temperature. Temperature decides the rate at which the adsorption can take place. And fourth important factor is the partial pressure of the adsorbed gas. So there are two different types of adsorption that can take place onto the solid surface. The type depends upon the nature of interaction that takes place between adsorbent and adsorbate. If the interaction is weaker kind of interaction because of the van der Waals forces of attraction that are happening between adsorbent and adsorbent, then that type of adsorption is known as physical adsorption. And if chemical bond formation is taking place between adsorbent and adsorbate, then that type of adsorption is known as chemisorption. So physical adsorption, because it is because of weaker van der Waals forces of attraction, these type of adsorptions are reversible, and desorption, which is the process of removal of adsorbed gas from the surface of adsorbent, it can be easily undertaken by either increasing the temperature or reducing the pressure. So physical adsorption, it is reversible, and adsorbed gas can be easily dissolved by increasing the temperature or reducing the pressure. Whereas in case of chemisorption, because chemical bond formation is taking place between adsorbent and adsorbate, it is irreversible. And if we want to separate adsorbent from adsorbate, then we will have to work against the bonds which have been formed, and we will have to break the bonds to separate those two materials. The very important concept in adsorption of gas taking place onto the solid surface is adsorption isotherm. Whenever we work onto the adsorption of gases, we need to understand the relationship between amount of the gas that gets physically adsorbed onto the solid surface and the equilibrium pressure of the gas which was present. We know that temperature affects the adsorption, and as we are talking about physical adsorption, desorption process takes place with increasing temperature. So if we want to understand the relationship between the amount of the gas that is getting adsorbed and its equilibrium pressure, then we will have to work at constant temperature, and that's why this relationship, it is being known as adsorption isotherm. We get this kind of graph when amount of gas X adsorbed per unit mass M of adsorbent, when it is plotted against pressure, we get this kind of curve, and this graph can be easily handled in terms of logarithmic form. So if we plot log of X by M, that is amount of gas adsorbed per unit mass of adsorbent, versus log pressure, then we get a straight line, and how this play an important role and how it helps us, we'll understand it when we'll be talking in our next lecture about different adsorption isotherm equations like Friendlich adsorption isotherm equation, we have Langmuir adsorption isotherm equation, and Bate adsorption isotherm equation. I hope the concept of adsorption of gases which takes place onto the solid surface is clear to you all. We'll be talking in detail about adsorption isotherm in our next lecture. Thank you.